Dun, dun, dun. Yes, hello everyone and welcome to another Benito's revision video. Now if you are watching this on the day it was uploaded, which, just thinking about it now I've just said that, doesn't seem very likely at all. But anyway, it is now 2 days till the double bill of Core 1, Core 2, back-to-back AQA AS Maths exam. It's all very exciting. So, yes, so I imagine people around the country are slightly bricking it at the moment, so let's do a revision video to, iron out the less confident bits. Now, I've managed to get hold of the January 2013 paper over here, so this is obviously the most recent one, and it is quite hard, I must admit, don't want to scare anyone or anything. So let's see, I found it quite hard, at least. So, let's do this, because this is really going to help me to revise, so let's see if I can help any of you lot as well. Now this is the one which I find a bit tricky. It's log, can you read that? Given that log to the base a of n minus log to the base a of x equals 1.5, express x in terms of a and n, giving you your answer in a form not involving logarithms. So let's write that out. Oh, and I am, by the way, if you're one of the people who has commented on the camera not being great, I completely agree with you. So, sorry about that. This is on a tablet. So I don't know how I'd position it, to be honest with you, other than with my hands. So anyway. So yeah, don't worry, I'm taking your comments on board. Anyway, so log to the base a of n, take away log to the base a of x equals 3 over 2. So this is obviously using our laws of logs. Now, if we have a log to the same base and we're taking them away, you should know we will actually divide the n and the x. So what we're saying, what are we doing? Log to the base a of n over x equals 3 over 2, or 1.5. Yeah? Now, we can express this in a way not involving logs by making n over x the subject. Because if we know what this means, we can say that a to the 3 over 2 is equal to n over x. Now, we're expressing, what are we expressing? X in terms of a and n at the minute. So, we can also write that as a to the 3 over 2 equals n x to the minus 1, can't we? So, if we put n on the other side, x to the minus 1 equals 3 over 2 over n. Then, if we get rid of this minus 1, so what do we do? I don't know how to say it. But you get rid of the minus 1 and put it on the other side. Yeah? Does that make sense? So you do, oh yeah, you find the reciprocal of this. Because this is 1 over x. So, if we find 1 over this, that'll give us x. Yeah? I feel as if I explained that absolutely terribly. But anyway, that, if you remember doing the gradient of the perpendicular in Core 1, you'd do the reciprocal, you'd flip these, wouldn't you? Well, that's exactly what we're going to do here. We're going to do n over a 3 over 2. So that means we can say that x equals n a to the minus 3 over 2. There we go. That's your answer. I'm going to try and do this quickly because I want to do another question in this. So that is your answer. That looks like sodium. Yeah, it's that. Anyway. So the point is, getting it into a verb not involving logarithms, but you still have to know what we say when we write this. The answer is the power. Yeah? And the big number in front of the base is the answer, as it were. So a to the power of 3 over 2 equals n over x. Then we've sort of fiddled with it a bit, messed around, and we finally got that. Yeah? Okay, let's do another question. Okay. Ooh. this is my sort of spastic light bubble. Okay, so let's find another question. So yeah, pause this when you feel you need to. I think question 5 was a bit of a muppet. This is to do with series. Part A is alright, it's just a classic geometric series question. Find the sum to infinity, write the end term, blah 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 blah. We're using a bit of our laws of indices in that one. But here, we go on to an arithmetic series. The first term of an arithmetic series is 240, and the common difference of the series is minus 8. The nth term of the series is un. Write down an expression for un, and this is worth 1 mark. So, this is pretty simple. It's just plugging numbers into an equation, and we can see in our formula book that the nth term of a series is given by a plus n minus 1 d, where a is the first term of the series, n is the number of terms, the term, right, the 5th term, 6th term, blah blah blah, and d is the common difference. So by plugging these numbers in, we can get 240, which they said is the first term, plus n minus 1, because remember we're looking for the nth term, so the n is going to stay in the equation, and we've got minus 8 here. So obviously expand the brackets there, so we've got 240 plus minus 8n plus 8, because minus times a minus makes a plus. And then we can just simplify that. So 240 plus 8 is 248 minus 8n. So that's your expression. Now the second part of the equation is a lot more complicated than that. So if you can't do that, you're pretty much stuffed. Okay. So, now this is I got no marks on this question because I didn't have a clue where to go. But I've looked at the mark scheme and I think I know how to get to it now. So let's see if I can explain them to you. Given that UK equals 0, find the value of sigma k n equals 1 un. How? I don't quite know how to say that really, but if you can't see it, I'm just drawing it here, hang on. Un. Now we've found an expression for un, so we can rub that out and write 248 minus 8n, because that's going to make that whole thing an awful lot simpler. And they're saying UK equals 0. Now the mistake I made, I interpret it as the sum of 1 to k equals 0. That's not true. We're saying that the kth term equals 0. If that's the easy way of saying it. So what we're saying is 248 minus 8k, because that's n is k at this point, equals 0. So from that, obviously, we can work out what k is, because 248 equals 8k. That means k, if I remember, is 31, if we shift some numbers into your calculator. So then, we can get rid of the k here, put 31. So we're finding of the sum of the first 31 terms of this series. And by this we can just look in the formula book. Sum of the n terms equals n over 2, that's a terrible 2, 2a plus n minus 1d. Or you could do first plus last times number of terms divided by 2. But I'm using this way. Old school. Hipster. Anyway. So, sum of the first 31 terms. N is 31, so 31 divided by 2 times 2 times, what was the first term? 240 plus n minus 1 is 30. 30 times minus 8. And I can tell you that answer gives you to a total of 3,720. And there we go. Well, I don't think we have any more time for anything more than that, so I must say, the transformation rules are a bit, actually they're alright, what am I talking about? The transformation rules are okay. The trig equations, which I'm not going to do, because, well, I've already done a video on trig equations anyway, no, that's binomial. They were pretty good for a core 2, I tell you. So I hope something like that comes up. Look at that. That was alright. 4 marks on that. So, yeah, thank you for watching. Good luck to everyone. I don't know whether I'll do another one tomorrow, but we'll see. But anyway, yeah, good luck, and yeah, let's do these exams.